So our goal now is to add a randomized scale onto our instances. We can see here they're all consistent. Over here we're having some of them small and then some of them big, applying a randomized scale. And our very first step is to do the random scale. So how do we do this? Where do we begin? What are we doing here? Well, at this point, we're working with our instances still. And we know this because our geometry spreadsheet is telling us that is where our data is. So if we want to modify these, a good place to start looking here is going to Add menu, and then we can go to our Instances menu. And now we can start controlling and modifying our already existing instances. And specifically, we can see here we have Rotate, Scale, Translate. We're going to be sticking with our scale instances. Then I'm going to plug that in between our set position and our output. And now we'll notice on the scale instances, we have access to another diamond, another field parameter, right? Now, in this particular case, it's a little bit weird because you can see, okay, well, they're still all the same. I thought fields made it to where we can do things a bit more randomized. In this particular case, we'll see that the actual diamond has a little dot in it. What that means is this is a field, but currently the field is all set to the same value. Specifically, they're all set to 1, 1, and 1. It is currently a uniform value. And if we change this here, we'll be changing them to all of them together. So what we want to do here is now add a random value. Go to Add menu, we'll go to our utilities, and then we'll have access to our random value math node. Now I'll click and drop that in before our scale instances here. And I'll go ahead and plug that value into our scale. So we're going from a diamond to a diamond. Now you'll notice a couple of different things here. One, we're working with a gray socket, and then we're putting that into a purple one. Basically what that means is this value is a float value. A float value is just a fancy word for a value that looks like this. It's just one value. Whereas in a vector has 3 values. And what that's going to do is automatically do a conversion for us, being nice and super user-friendly for us. And it's going to put that one value into the scale X, Y, Z, those 3 values. And there we go. Now we can see that our net scale is now randomized. Now for you, you might not be able to see this, but if you're looking in the 3D view, you might be like, okay, well, I don't even see anything. But if you go into your top view, you'll be able to see that a little bit better. Now, okay, this brings us to step number 2, which is getting to know the difference between noises and random values. Now, earlier we worked with this noise texture. In terms of functionality, it's very, very similar to the random value node. But why is it so important that we know the difference between these two? Well, what a noise texture does is it works with a positional data. So by default, the vector input of the noise texture works from a 3-dimensional position space, meaning it's working with the position coordinates, which means it can generate a noise pattern in 3-dimensional space by default. Okay, so why is that important to us? Well, if we look at the random value node, the value that it works with by default is the ID value. Okay, well, why is that important to us? If we go to our instances in our geometry node spreadsheet, we'll see that we have an ID right here on the left side, 0, 1, 2, 3, 4. And then over here, we have our positional data. Our positional data is going to change as we animate. You can see as I move in my time slider and pause, these values change. So the reason why we can't use the noise pattern specifically here is because as the noise pattern causes the animation to move up and down, these values will change, which means the dust particles would be changing in scale up and down as well. So that is why it's so important that we use the random value here with the ID, because the ID stays static no matter what we do in context of animation. And we'll continue in the next chapter.